Okay, great. So we can get started here as people start to come in. I would love to give a quick introduction for those who are not familiar with you. Um, yeah, Vishwakarma Singh is presently ML Tech Lead for Trust and Safety at Pinterest, where he has led successful development and productionization of state-of-the-art solutions for filtering spam, unsafe content, and fake content. Previously, he worked as a principal ML scientist and engineer at Apple. He has a PhD in computer science from UCSB, Santa Barbara, and he has published many papers in peer-reviewed conferences and journals. It's a great pleasure to have you here, Vishwakarma, and thank you so much. I will let you get started here. And for those who are attending and watching, please feel free to put your questions in the chat, and we can get to those after. So with that being said, Vishwakarma, thank you so much.
Thank you, David, for introduction. So I am Vishwakarma Singh. I am an applied machine learning researcher in ATZ group at Pinterest. And I also lead machine learning initiative for trust and safety at Pinterest. So today I will be talking about how do we use machine learning for trust and safety at Pinterest. So agenda will be like, I will give some background to introduce what trust and safety means, what we do, and then I will give an overview of some of the models that we have developed and successfully operationalized. I will also talk about the technology stack that we use in trust and safety for productionizing these signals. And then I will talk about some of the challenges, and at the end we can have a Q&A session. So millions of users come on Pinterest every day, either to create a pin for what they love, or they want to search for ideas or inspirations. But there are some users who try to misuse the platform for their personal gain, or just they create content which is policy violating. And that's where trust and safety team at Pinterest comes in. Our responsibility is to enforce content policy, what can be created and distributed on Pinterest, like adult content, hateful activities. These are like against the content policy, harassment, criticism, self-injury kind of content. Similarly, spam, we fight spam on day-to-day basis, or account takeovers, or hateful activities, or misinformation, or fake information. So that's the another pillar. And third is like maintaining legal compliance with the laws. So these are the three pillars I will be mostly touching: enforce in content policy, and how do we fight adversarial behavior with machine learning models. So our team consists of developers who develop machine learning models. Then there are a group of analysts, because to find the trends and to find all these issues, you need analysts to see the data and figure these problems out. To support the signal developers, we have platform engineers and tooling engineers. We also have a set of folks who works with legal, because it's very legal binding work. We try to adhere to the legal compliance. And then we have PMs and EMs. We partner very closely with many other teams, which is a spam and ads operation. We need policies around content. So there is a policy team. There is another operations team to support trust and safety, legal, product owners, and security. So why trust and safety problem is so complex? Either we see for adversarial behavior that includes misinformation or spam, or if we see from content safety perspective, like creation and distribution of unsafe content. So if you see, there are a lot of, if you go on Pinterest, there are a lot of entities on Pinterest, and there are challenges across each of these entities, because pinners or users can misuse any of these entities to either create or distribute unsafe content or spam. So user themselves, they can create fake accounts, or they can do account takeovers. Then when you create a pin on Pinterest, it also has link to the website from where that image was pinned. So that link can be exploited or misused to spread unsafe content or spam or malware. Similarly, images and videos can be prone to unsafe content distributions, pins themselves, boards, and text. So there is a spectrum of complex entities that can be exploited, and we have to develop signals around these complex entities to fight distribution of unsafe content or creation, and also to fight spam. If that is not enough, other things that make it very challenging is the adversarial behavior of spammers. If you do something, then they react to your technique and try to navigate through that mechanism to again reuse the platform for spamming. Then there is like continuously changing world dynamics. If you have COVID, then there's a lot of misinformation around COVID floating around. If your election, there's a lot of misinformation around election. Now we'll have vaccines, so there'll be a lot of, like there will be a tsunami of misinformation from different groups to misuse the platform to distribute their ideas. And again, like varying national, and you have to comply with varying national and international laws. Like marijuana is like very different in different states in USA. So these are the different complexities that we deal with. Our approach to tackle trust and safety is like twofold. One is reactive. So you want to be prepared if something happens, you want to firefight that thing. Like if there is a spam attack, you want to firefight it. We also enable our users to report such misuse of platform. Like you can say that this pin is against Pinterest content policy, or this user you behave is harassing you or is a spammer. So whatever the user is reported, it goes through a human reviewer, and then we ascertain whether it's a right report or not. So we do a reactive approach. We support that heavily with a proactive approach. What does it mean? Like we create a machine learning models that can catch all this bad stuff beforehand and filter it before it gets distributed to other users. And there we enforce policies using these machine learning models. Proactiveness also comes from some of the rules that we use to support our ML models. And then when we develop the ML models, we use both content and the behavior. Content is like what is the image, what is the text, what is the link. So you want to extract the content out of it and understand the content and develop a machine learning model around the content. Behavior of the users on the platform is another thing that we use to detect whether a user is a spammy or the content they have created is unsafe or spammy. So there we look at their activity rate, interactions, similarity, image reuse, resource reuse, and collusion. So this is our approach, and I will be digging more into the ML models as we go. We are also active in community, so we'll be hosting Trust and Safety Machine Learning Summit in January. And this will focus on how to use machine learning for trust and safety specifically. If you are interested, you can RSVP at pinterestmachinelearning.splashdot.com. So going forward, like now I will give an overview of the models that we have developed, and in two categories like content safety and spam. So let's start with content safety first. What is content safety? So we have policies around what kind of content can be created on Pinterest and distributed. So any policy violating content that bring bad experiences to pinners is called content safety problem or a harmful content. There are multiple entities around it, like images, videos. You can create a video that can offend somebody or a society, text, pins, boards, and there are multitude of categories in content safety. We create a category to better tackle the problem, like porn, medical misinformation, hate speech, violence, drugs, self-harm, harassment, bullying, political misinformation, guns, and many more. Let's look into some of the models that we have developed. So first is a batch multi-category DNN model that we use to filter unsafe content. It is a pin classifier. So what it does, it takes the image and we extract visual embeddings from each image. I have put a reference in the slide later if you want to read more about unified visual embeddings that we do at Pinterest. It's a multitask model that extracts embedding from the images. So that is the one input that we use. We also derive annotations from the pin descriptions and the title and the name. Then we use the pin and board graph. And from the images, we also extract OCR text. So these three inputs are fed into a model that is called PINSES. It's a graph convolutional network derived from GraphSys, and that gives us an embedding for each pin. We support that with the OCR text. Finally, we support it with a MLP multi-layer that is called multi-category DNN, and this is used to classify a pin as one of the unsafe categories or safe category. So this is our primary model for handling content safety. This is trained in TensorFlow, and the inference again happens in TensorFlow using PySpark, Spark SQL, and UDF. And this runs as a batch job periodically on billions of pins that we have. This runs in an offline mode. We have a multi-tier solution for it. So we also have a near real-time multi-category DNN. So this is differentiated from the offline, is like this runs periodically and you compute the score. This one, the near real-time, kicks in as soon as a pin is created. So as soon as a pin is created, we extract the visual embeddings from it and instant annotations. We feed into our instant PINSES embedding, we extract the embeddings, then feed into our multi-category DNN, and that gives us a score for one of the unsafe categories or the safe. So this is instant, and it helps us to block a lot of bad content very, very proactively. The inference here happens using TensorFlow in Flink as a streaming job. How these two sit in our system is like this. So when a user does the activity, either pin create or pin repin, we take the pin, we extract the visual embeddings, instant annotations, then we do the generation of instant PINSES embeddings. Then it goes to our Flink machine where we run the trust and safety classification model. Using TensorFlow, we do the inference, and then it goes into a mutable database and it's served through a services. For all the pre-existing pins, we have the OCR and PINSES embeddings. We run our classifier and do the inference using TensorFlow, UDF, Spark SQL, and PySpark, and we are storing another database. When a user is creating a pin or repin, we first probe our online database to see if there is a score for this pin or not. If the pin has for instantly created pin, if there is a score, then we'll use it. And we also check our pre-computed scores to see if there is a score for it. So this is preferred over the instant one, because this has a better performance as it uses much more complex features which may not be supported in near real time. So we first check the read-only database of offline computed score, and then we fall back on the instant score. And that's how we filter in the near real time all the bad content. If a user is reporting, then it goes through a human review process. We have a in-house built PinQ system that supports that, and I put a reference for that. Many of the data that is generated from the human reviews are used by us to train many of these models. So that was a system overview of how we use machine learning model for content safety. There are some other models, but these two are the primary signals that we use. There are other signals that support these two models. Next, let's talk about a spam. So a spam is another big problem on any platform that have user created content, and on Pinterest also we see this problem. So we define a spam as an action or behavior that is intended towards abusing the platform for monetary benefit. So somebody is trying to misuse the platform to extract or earn money from it. The way how they can do is, one of the ways is like, you are a user, you go create a pin on Pinterest, and what you do is you link it to a web page that is spammy. So that's the one way of doing it and misusing, and that's the one way it's misused. You can also misuse like comments. You can also misuse the board titles and the pin titles. So there are a lot of places that can be misused. We especially focus on how to catch spammy actors or the users, and how to filter domains and comments which can be spammy. So the ML approach for spam covers a broader spectrum. Like we look into the link domains, and we have developed a suite of models to handle or identify domains or links which are spamious. For users, we have developed supervised as well as unsupervised techniques to catch spammy users. And we also use the relationship between domains and user in a graph setting to find out which are spammy users or which may be spammy links or domains. So I will focus on few of the classifiers from the domain side and few of the classifier on the users models from the user side. So this is one of the signals that we use to identify spammy domains or links at Pinterest. So given a link or a domain, it will say whether this domain is a spammy or not a spammy. So what we do is like for a domain, we sample a set of links. We do a text-based CNN on that. We also craft pinner features like users features. For domains, we create a features. Then we also use the landing web page content to create some features. We all input that into a joint representation, and then we top it with the MLP layer, and that classifies whether that particular domain is a spammy or not a spammy. Again, this is operationalized using TensorFlow in PySpark and UDF and does periodic offline inference. There are other signals for domain because it's a very complex thing to tackle with just one signal because of moving parts. So we have a web page model that just focuses on the content of the web page and tries to infer whether the web page itself is spammy or not, and it can be used in near real-time setting. As soon as somebody creates a pin, we can take the page and infer whether the web page is spammy or not spammy. We also have another real-time signal which is just based on the links. So if you see the links, there are many very informative many a times, and you can use the information in the links to figure out whether it's pointing to a spammy page or not. And these two signals are very good in near real-time scenarios. So as soon as a user is creating a pin and they're linking to a web page, you can run these models and proactively take action on them, and there is no delay in that. Some of the user signals that we have created is like one is like using users and domain bipartite graph. We do a label propagation on it, and that's how we find out whether remaining users are spammy and remaining domains which are not labeled are spammy or not spammy. This we have operationalized using Spark, and it also does a periodic offline inference. There are many other user signals that we have. One is like just we do a scalable grouping of millions of users based on behavior to catch low-hanging fruits. Then we have sophisticated methods like clustering. We do a graph-based clustering on behavior and content. We also have a supervised classifier where we classify spam users based on their actions and interactions with other users and entities on the platform. So that was the overview of some of the signals that we have developed. Let's take a look into what technology stack we use. So for training, we mostly use AWS GPU machines. And for inference, also we use AWS machine. For offline setting, we have Airflow-based workflow that runs most of the offline jobs. And we use a Spark, PySpark, whole Spark stack for doing inference supported by UDF and using TensorFlow Java inference library. For near real time, we still use TensorFlow for inference, but we use Apache Flink as a streaming platform. Some of the challenges that come for trust and safety machine learning model development and productionizations are these. So trust and safety is a very challenging and a specific issue. And creating label data for supervised models is very time consuming and costly affair. And there are so many cases that many a times you may not have even like a seed data to start with. So that still remains a very challenging problem. We use some unsupervised techniques to circumvent the problem and generate data set in a cost effective manner. The second is like since these problems are very adversarial and are guided by dynamic nature, so you have to keep the models fresh. That means you have to retrain them very often, or to catch a very new trend that is peaking on the platform and that is abusive. You quickly want to retrain these models with fresh data and again apply them. So model freshness is another big challenge. A quick detection and reaction to new trends. How do you first detect the trend and then how do you make these models reactive enough to react to those new trends? Another thing that is not very common in other machine learning fields, which is like if you are doing recommendation systems or search systems or ranking, you generally rely on machine learning engineers and experts to do that work for you. But in trust and safety, just few machine learning engineers are not enough. You have to enable analysts, PMs, and everybody to effectively address the problem. So democratization of machine learning is a very vital requirement for machine learning to succeed for trust and safety. And we focus on democratization of machine learning in our team. So these are some of the challenges. This is the reference which I used earlier. This is the page for paper for unified embedding, graph convolutional network pinces, PinQ, keyword extraction that we do for annotations, and the label propagation that I talked about. So that's all my talk. Now I can take questions and answer them if there are any questions.
Thanks, Rukmana. Okay, so we do have some questions here. I had one in particular, and you might not be able to discuss this, but when you mentioned that you do some clustering, classification, grouping around um, some of the sort of abuse detection or ways in which there's, as you described, like some low-hanging fruit, is there any other flags that you could discuss? I'm just really curious of what you would be able to flag when you have those large groups with something like clustering or classification.
So to tackle trust and safety, it's a tiered solution that we do. So what happens, like on daily basis, you will first do a very basic grouping based on attributes of the users and their content there, and that will give you some benefit. Like you will be able to, because to a spam, one of the incentive is to make money, and so there the spammer has to make some profit to spam the platform. If you can make that costly for them not to earn any profit out of it, they will not do it. That's the, so many times what they do is like they reuse their resources to spam you. So they will recycle their IPs, they will recycle their devices, they will recycle their accounts. So that's a low hanging fruit. You can just do grouping, and that will give you some delta progress on that. But going beyond that, you have to again deploy sophisticated clustering techniques that is able to capture collusion between the users and how they are creating content over a period of time, and that becomes sophisticated. Cluster them, catch patterns with the cluster, and that's where the most interesting part of the machine learning starts coming into play.
Is there one technique that catches the low-hanging fruit more than another?
No, there is not like that. You have to deploy a spectrum of models, and even in low-hanging fruit, like Grouping is one. Similarly, you can do something for web pages if they're trying to reuse the same kind of, suppose you have a DOM generator. You use a tool, it's generating your DOMs for you. So there also duplicacy is maybe a big problem for the people who are trying to create unsafe content. So there again, you can do some kind of grouping, but that grouping is supported by sophisticated method of catching web similarity. And web similarity at a scale you can do with some min hash or those kind of techniques. So fundamentally, that is going to be a grouping, but that will be supported by quantization or min hash kind of technique, where you quantize the web page and then you try to capture the similarity between them.
That's great. Thank you. I think Faraz is going to join us. There's a couple more questions, so I'll get off screen. But just to cue you up, Faraz did ask at what stage. Oh, here's Faraz. Faraz, if you can continue with the question.
Yes, I will. Yeah. Hey, thank you so much for the great talk. It does look like we have 2 more questions. I just wanted to understand kind of at what stage does a human reviewer come into the loop for the review? You had mentioned that you have 2 different teams, I suppose. Well, one is the automation and then one is the human review. So at what point do they come in?
So mostly we use human reviewers. So what happens is like we also enable our users of the platform to report issues on the platform.
Mm-hmm.
But that has to be very transparent, and users has to know that if they have reported something, that is getting actioned on.
Mm-hmm.
So there is a automated flow. As soon as users raise a issue, it goes through a pipeline and it ends up in a queue for the reviewers, and then we review it.
Mm-hmm.
And we decide whether it's meeting the policy or it's violating the policy, and we label it. And that action is propagated across the system, whatever the action is taking. So that is one place where we use human reviewers. Even in machine learning, if there is a low confidence decision, it can flow to the human reviewers. That is another place. So high confidence versus low confidence, because it's a tiered solution.
Mm-hmm.
Plus, when you are taking actions on the users, we have a high transparency around it. So we have to let the users why we are taking an action against them, and they can appeal that action. Like somebody is taking an action against me.
Mm-hmm.
And we spend a lot of time reviewing those claims. So that claim has to be reviewed, and they have to be told why action was taken on them.
Mm-hmm.
So at least 3 places we use human reviewers at this time.
Mm-hmm. Interesting, yeah. So then what does your team structure looks like?
Team structure is, let me go to the slide.
Mm-hmm.
Yeah. So if you see, like, there is a team that develops these models,
mm-hmm.
but that has to be productionized. So there is a platform team that bridges the gap with the Signal developers and other platform developers at Pinterest.
Mm-hmm.
So that's the platform team. It's a small team. It's just to bridge the gap from developers to other platform developers at Pinterest. There is a data engineering team. There is an infrastructure team. There is an ML platform team.
Mm-hmm.
Separate org, but somebody needs to coordinate and get these things. So we have a platform team.
Mm-hmm.
We have a tooling team to support a lot of the things that we do in like human review tools, right? Like you need to support that human review tool.
Mm-hmm.
Or you take an action, you need to send notification to the users why action. So a lot of tooling is required.
Mm-hmm.
So there is a tooling team. There are analysts who are on the front of fighting all the abuse. So they take the data, they run sophisticated SQL queries to find any kind of new trends or address firefighting issues and all that. So there is a set of analysts.
Mm-hmm.
Then there is a legalist team that works with the legal team, because everything that we do is legal bounded. What you can do, what you cannot do, freedom of speech. There is a lot of rules around drugs. There is a lot of laws around child pornography and all that. So there is a legalist team that work with legal team at Pinterest to make sure that we are addressing all the legal clauses.
Right.
And then there are PMs and EMs. Then we have operations team that helps us, user services team, policy team, and different product owners works with us very closely to address trust and safety.
Interesting, yeah. So what does the cadence looks like from a user or a moderator flagging a pin to actually taking it down to contacting the user? Like what does, like how quickly does that
It goes pretty quickly as soon as, because most of the work, like all the workflow is like automated. There is not much of a human intervention. The only bottleneck is human capacity. How many reviewers you are having to review. So as soon as you flag, it lands into one of the queues, and then first come, first serve, they are served. We look into each and every pin and each and every report that comes to us, and then we make a decision. As soon as the decision is done, then it's again automated to send a notification to the user, or also find that out to other places, like this action has been taken on this pin, so that pin never resurfaces on the surface Pinterest.
Interesting, yeah. Yeah, like there's also a lot of users share their pins across platforms, right? So like if it's on the website, if it's on their blog, I think it's good to see that the actions are taken fairly quickly. So that's good. It's awesome. I think that's all the questions we had. Thank you so much for a great presentation, and also thank you so much for joining the community as well.
Thank you.
Thank you. It was a pleasure. Okay. Thanks, everyone.